Hi, this is Mr. Fiducia. I want to show you an example of a normal probability problem, one that's a bit different than the one I showed in my previous video. And also I noticed a problem similar to this appears in your upcoming project 4, project assignment number 4. What it says here is that a high school math test was given to some high school seniors, and it resulted in an average or mean score of 200 and a standard deviation of 48 points. And it also tells us that the test scores are normally distributed. So what we can do then is we can draw this sketch of the bell-shaped curve, the normal curve. We can label the mean right in the middle here as 200, and we know that if we can add 1, 2, 3 standard deviations above the mean by adding 48 to 200 and then adding 48 to 248 and so on and so forth. Now, the question is, um, the question is that a local engineering school will accept only those students who score in the top 10% of math scores. I originally put that as 20, but I meant for it to be 10. So in other words, if you're in the top 10%, then you're going to be admitted to this engineering school. The question is, what is the minimum math score you can get and still be in the top 10%? Well, the top 10% is in here someplace. We don't know where it is, but we do know that this part of the curve right there in the tail represents the 10% mark. And so what we know is that this probability right here is 10%, this shaded tail right in here. But it also means, importantly, that the 90% 0.90 of the scores, or 90% of the scores, right, are less than whatever this number is. See, we're trying to find this test score number. We don't know what it is. I just put that line somewhere. Had no idea where it was. But I do know that you have to be in this top 10% in order to be admitted. So the question is, what is the score that represents the top 10%? So in order to do that, we can go to Excel. And this time, what we're going to do is we're going to go into the inverse normal. You see, it returns the inverse of the normal distribution, because normally we're looking for a probability. But in this case, we know the probability, it's 0.9. What we're looking for is the test score, the value on the horizontal axis. And so what we want to do then is put in the probability. Now here's the important part. The probability that we want to put in is all the area below that minimum value. And we know that that's, since they want the top 10%, the area below it has got to be 0.9. It also tells us the mean is 200 and that the standard deviation is 48. And there it comes right there. It says that the minimum score to be in the top 10% is 261.5. Well, that's going to be in here someplace. There's 248. There's 286. It's going to be in here someplace. I guessed wrong. And so this value that we're interested in is 261.5. You need to get a 261.5 or more to be in the top 10%. Hope this helps. Any questions, afiducia@kaplan.edu.